So I take this problem, this looks very, very ugly, and it is, but really what you've got is you've got four factoring problems and one big multiplication or division problem. So I'm going to factor each one of these pieces. Remember, I can't cancel like this x squared here and that x squared. I can't cancel those because I can only cancel something that is a factor of the entire numerator with something that's a factor of the entire denominator. That's just what you have to do. And I could explain why, but I've done that too many times. So we're going to factor this, and remember that's a quadratic, so I'm going to have that something x.
Thank you.
So
negative.
I'm just going to guess and check. I'm going to guess 4 and 3 because that's got to be 12x squared, right? And then negative 12y squared. I'm going to guess. Notice I wanted to add to 7, so I'm going to guess. Let's see. I'm going to guess this is going to be plus 4 maybe, and this is going to be minus 3. Let's see if that worked. This becomes negative 9, and that becomes positive 16. And look at that, I happen to be right, because 16xy minus 9xy is 7xy. So that's how that factors. Now let's try the other ones. You go ahead and pause the video and try it yourself. So this bottom part is going to break up into, again, you're going to try to find a way to break up 28x squared and 3y squared in such a way that when you add them together you're going to get 25. Now I look at it right away and I think, well, 28 minus 3 is 25. So I'm going to try to do it. Let's see if that works. I don't know if that will work. 28x and 1x. And now I want to make this a negative y
like appearance-wise
and a positive
we have like the same body
3y. Whoops. No, that doesn't work because it's not negative. Dang it, that won't work. If this was negative, that would have worked, but that's not negative. I wasn't really paying attention to that. So let's try something else.
Wait, how did that
It's not going to be 28. It's going to be, let's try it. I'm just following my nose. Let's try 14 and 2. Because 28 is 14 times 2. Now let's break up 3y squared into something so that multiplies to 3y squared. So that when I FOIL it out, I'm going to get the negative 25xy in the middle. That's what I'm after. They both have to be negative, right? So let's try making this negative y and negative 3y. That's going to give me negative 14xy minus 6xy, which isn't quite 25. Negative 25, it's negative 20. So that didn't work. So let's guess something else. If I put the 3 right here, that would be too much, because now that would be 14 times 3, which is way too big, so that's not going to be it. So how about we erase this, and we make this, 28 can break up instead of 14, instead of 14 and 2, it's going to be, let's try 7 and 4. 7 times 4, and now let's try to break this up in such a way, I think this is going to work. Let's put a 3 here and a 1 here. What's 4x times negative 1y? It's negative 4x, negative 21. What's negative 21 minus 4? Negative 25. So that worked out. One other trick that you could do is you can look up here and say, I bet you it's going to be one of these two, because it's probably going to cancel. That's another trick you can use, and so I maybe should have looked at that first and said, oh yeah, let's try one of these two. And sure enough, those now are going to cancel out. Let's use that same method to try to factor these other two. Whoops, didn't mean to do. So this is times. This is going to break into, let's see if I can get somehow 7. Remember, this one right here is going to be on the top because of the division, right? So that's the one that's going up here. And let's just go ahead and take a guess that it's going to be 7x minus 1, because that way it'll cancel with that, right? If that's 7, this has to be 3x. And if this is minus 1, I'm sorry, y, not just minus 1. If that's minus 1y, then this has to be minus 4y. And let's see if that worked. What's negative 3xy minus 28xy? Negative 31, it did work. So these, it looks really hard, but once you do one, the other ones kind of fall into place. So those cancel. See how those canceled? And now the bottom, which is right here, let me color code this again, do gray. That one right there is going to be on the bottom right here. And let's try, it's probably going to be one of those, if not both of them. So let's try 3x plus 4y. If 3x plus 4y was there, then this would have to be 3x, and this would have to be 4y. The problem is they're both going to have to be what? They're both going to have to be negative for this to work. So you see why? Because you had a 16 here, you had a positive 16, and this was a negative 24xy. So this had to be both negatives, but that's okay, because that worked, right? Negative 12 and negative 12 is negative 24xy. So this is going to cancel with this, or you could have chosen the one, either one, it didn't matter. One of them is going to stay, one of them is going to go. So all you have left is 3x plus 4y all over 3x minus 4y. Now, big question, can I cancel the 3's?
No.
Or the x's, or the 4's, or the y's? Heck no, I can't cancel. Why? Because they're not factors of the entire numerator and the entire denominator. This is your answer. One other thing you could do to check to see if you did it right, this is a little fun trick I like to do. Plug in like 1 for x. If you have a graphing calculator, plug in 1 for x and maybe even y also. Plug in 1 for x and y in your graphing calculator. When you do it into this expression, we can actually do that in our head. If you plugged in 1 for x and y, you would get 3 plus 4, which is 7, over 3 minus 4, which is negative 1. So you'd get negative 7, right? And if you plugged in 1 for x and y into all of those things up there, I know it looks daunting and difficult, but it's really not that hard. It's just going to be 12 plus 7 minus 12, so this is 7, over 28 minus 25, which is 3, plus 3, which is 6. See what I did there? Times 1, 1, 1. Plug 1 in everywhere up here. You're going to get 9 plus 16 is 25, minus 24, which is 1, over, I'm sorry, that 1 is going to be on the bottom, right, because it's divided by. So there's a 1 on the bottom, and I bet you it's going to be a negative 6 when I plug it into here. When I plug in 1 into here, it becomes 25 minus 31, which is negative 6. So those 6's cancel, and you get negative 7. You get the same thing, whether you plug it into the original one or the simplified one. Why? Because they're the same thing. These are the same expression. This is the bottom. The bottom is just simplified, a simplified version of that big nasty thing you had at the very beginning. So you could check your answer by picking any values you want and plugging them in and seeing if that gives you the same thing on the top and bottom. Hopefully that made sense.